Hey guys, so I usually tend to keep my lessons very short, but today's video is going to be a little bit longer because I think that if I divide it, then it might not make that much sense. So the idea that we're going to introduce in today's video is that we can think of our random variable x on two levels. So basically, we're going to introduce the double structure of a random variable. Let's call it x, okay? So we're thinking of this random variable on two levels. The first level is the stage when we're basically at the planning stage and we have not yet obtained any observations. So at that stage, we denote that random variable with the uppercase. This is the uppercase. That is the capital letter X. But once we actually obtain observations, and these observations we are going to refer to these as realizations, that's the technical term for this. So once we have obtained certain observations, then we're going to use the lowercase x for these observations, okay? So this is the lowercase. So we're thinking of the random variable x on these two different levels, okay? So that's the first thing. The other thing is that when we think of a random variable x, we have to remember that we must distinguish between x bar, that is the estimator, and the small x, which is the estimate. So this is our random variable. Okay, RV is for random variable. This is our estimator. And this right here is going to be our estimate. So we are using the lowercase for the estimate again. Okay, so remember that these distinctions are very important. Okay, so we're going to see the distributions for our random variable x. So the left one is the distribution for our random variable x, and on the right hand side we will draw the distribution for our estimator, that is x bar. Okay, and these distinctions are very important, but if you're not clear as to why we have these two different distributions, then I would recommend that you go through the video. I'm going to leave a link in the description box below. So it's from Khan Academy, and that will help you revise the basic statistics that is behind these diagrams. So this is the probability density function, okay, of our random variable x, and this one is probability density function of x bar. Okay, so now notice that for this one on the left hand side, this one is our distribution for x, that is our random variable, and this is mu x, the population mean. And on the right hand side, I'm going to draw the distribution for x bar, that is our estimator. Okay, cool. So this is our estimator. Now notice that the mean is the same. So the mean, that is mu x, is exactly the same for both the random variable x and our estimator x bar, okay? But the variance is not the same. So the variance, as you can see, is smaller for our estimator, that is x bar has a smaller variance as compared to x, the random variable, okay? So these are two different distributions, and basically I'm going to prove in the next part of this video that we can actually show, mathematically we can prove that the expected value of x bar is equal to mu x, but the variance of x is not equal. So the variance of x, sigma squared x, is not equal to the variance of x bar. As a matter of fact, we're going to see that the variance of X bar, that is our estimator, is smaller than the variance of X, our random variable, okay? So we're going to prove these two in the next part of this video. So that's it for today. Thank you.